All right, I'm recording now. Okay, perfect. So, I mean, as I said last week, I mean, normal distributions are, I would say, the most important continuous distributions, right? And um, and then we discussed the standard normal distribution. So we said, so a standard normal distribution, it's a normal distribution, right? And with the mean mu equal to 0 and the standard deviation sigma equal to 1, right? So let me just remind you what we discussed Wednesday last week. So we said a standard normal distribution. It's a normal distribution with mean mu. So the mean mu equals to 0, and standard deviation sigma equal to 1, right? So the idea is the following, guys. So what you really have to keep in mind is the following. So you have the graph of the standard normal distribution. So you have the graph, all right? And then, so this is your, we're gonna use the variable z for standard normal distribution. And then, so here's your graph. So this is the graph of the standard normal distribution. And what we are saying is that, so the mean is, mu is 0. So our mean mu is 0. All right. And then the standard deviation is sigma is 1. So like you're going to have like, so here this is like mu plus sigma. So that's like 0 plus 1, right? Because sigma is 1, mu is 0. So 0 plus 1, that will be equal to 1. So this is like 1. Here, this is like mu plus 2 sigma. So that will be 2. Mu plus 3 sigma, that will be 3. Now, if you subtract sigma, mu minus 1 sigma, because, again, sigma is 1. So if you do mu minus sigma, so this is like 0 minus 1. So that's negative 1, right? So this is like negative 1 here, which is, again, this is supposed to be mu minus sigma. Negative 2, this is like mu minus, 2 sigma, etc. Now, the idea is the following. So if we need to compute, let's say, a probability that your variable z is less than some number, right? So let's say you want to compute probability that the z is the variable. So the this is the variable of the standard normal distribution. So for example, like in a binomial distribution, the variable was r, right? The number of successes. So we denote the variable of a standard normal distribution by z. It's just it's just a convention. Variable of the standard normal distribution. So anyway, so the idea is if you want to find like the probability that this variable z, so you can think of z, for example, I don't know, it's some variable. So it's, for example, it's a continuous variable. So for example, z is the time to get on campus, right? For example. And you are looking for the probability that your z is less than, I don't know, let's say 1.5. Okay. You are looking for the probability that, so the time to get on campus is less than 1 hour and a half. Okay. So the idea is to find this probability, you need to, so you have your, you have your 1.5. So 1.5, of course, it's between 1 and 2, right? This is your 1.5. And to find this probability that z is less than 1.5, you're supposed to compute the area on the left of 1.5, right? So this is your 1.5. So the area on the left, you see this this green region. So the area of this green region, that's the probability that your variable is less than 1.5. Right. So this is the area of the region to the left of 1.5. Okay. And of course, you need to keep in mind that the total area under the graph, it's always equal to 1, right? So the area, so the area of the region under the graph, so the total area under the graph, this is under the graph is always is equal to 1. Under the graph is equal to 1, which is 100%. Right. So this, like this, the area of this green region would be some, it would be some decimal less than 1, right? It's going to be some decimal between 0 and 1, and that's exactly, definition of probability. Remember probability, the answer, when you try to compute the probability, the answer is always a number between 0 and 1. Okay. Anyway, so so what I said on Wednesday last week, so we can find this area of this region using the table number 3 in the in the formula sheet. So to find the area to the left of 1.5 or any number of some number to the left of some z, we use table number 3 in the formula sheet. All right. So I'm gonna try to share my screen and share with you the formula sheet so you can see what I'm talking about here. I mean, you can download, I can send you, well, I can post the formula sheet on Queenie Blackboard, or you can, I can just email it to you. So let me just share my formula sheet. So I'm gonna stop sharing. So we stop sharing. Okay. Stop sharing. No, oh yeah, it's here actually. Sorry about that. Yeah, stop share right here. All right, so I'm gonna share my screen. Where is my formula sheet? I think this one here. All right. Do you see the formula sheet, guys?
Yes.
Thank you. All right. So if you go to the table number 3, right? This is table number 2. We use the table number 2 to compute the binomial distribution. Now for table number 3, where is it? Right, still table number 2. Here is the table number 3. So you see the table number 3. So as you can see, the table entry for z is the area to the left of z. So let me just explain how to get the area. So you see there's this z here, and then in this the first column, we have like a negative 3.4, negative 3.3, negative 3.2, etc. That's like the nearest 10th. And then here you have like 0.00, 0.01, 0.02, 0.003, etc. That's like the nearest 100th. So for example, we have 1.5, right? So this first page here, we have like negative values of Z, right? This is like negative, 3.5, negative 3.3. This is just for negative values of Z. Now for positive values of Z, you need to move to the next page. So in the next page, you see the first column, the values of Z are positive, right? The 0.0, 0.1, that are positive. So we need 1.5 or 1.50, right? So the first column, that's the nearest 10th. So we need the 1.5. You see there the 1.5, and then the nearest hundredth. Of course, it's 1.50. So the nearest hundredth would be 0.00. So then the area to the left of Z would be this number here, the 0.9332, right? So you see 1.5, that's the nearest tenth, and the nearest hundredth, that's 0.00. For example, if I had 1.56, so 1.56, first nearest hundredth would be 1.5, right? So it's going to be this this row here, and then I said 0.56, right? And then so the nearest hundredth would be the 0.06. So we need to go to this column right here, and with the 1.5, so the answer would be this number here. Okay. So, okay, let me show you again with another example. I'm gonna probably stop sharing, but this is the table I'm talking about, right? This is the formula sheet I'm talking about. So I'm gonna just stop sharing here, okay? And so I'm gonna share again my board screen. All right. Oh, where's my, okay. Okay, still opening. Come on. All right. Yes. So here's another example, guys. So if you, let's say you want to find, instead of 1.5, let's say you want to find example number 2. So we want to find probability that Z is, let's say, less than 1.52. All right. So when you take the number 1.52, the nearest 10th, that's the digit just after the decimal point. So the nearest 10th, that's the 0.5, 1.5, right? And then the nearest hundredth, nearest hundredth. Right. So that would be the next, the second digit, right? The 2 here. So that's the 0.02. Okay. So in the table, so what we do is you take, of course, this is positive. This is positive, plus it's a positive. So you need to go to the second page in the table number 3, and then you have your Z, right? And you have like in the second page you have like 0.0, 0.1, etc. And then you have, let's say, somewhere 1.5. And again, guys, the first page is for negative Z, and the second page is for positive Z. Okay, so just be careful with the sign. Now, nearest 10th, we have like 0.00, and then you have like 0.01, 0.0, sorry, 0.02, etc. And then the last column you have like 0.09, right? Anyway, so like in our case, we said the nearest sorry, Nearest 10th is 1.5. Sorry, nearest 10th is 1.5, and nearest the 100th it's 0.02, right? So here's my nearest 100th. So the number, the answer would be this number, which is, let me just check my note, my table again. So for 1.52, well, any guess, guys? I mean, I don't know if you have the
93.57.
93.57. Thank you. Absolutely. So let me just double check. Yeah, 93.57. Thank you so much. So this is 0.9357. Okay, so then the answer, the probability that that z, your variable z, is less than 1.52, for example. So that's 0.9357, which is in percentage. That will be, you take 2 digits, you know, after the decimal point. So that's 93.57%. Okay. But what you need to keep in mind, guys, is that the table gives you the area to the left of z, right? That's the area to the left of z. This is, so this is when you have less means to the left of 1.52, right? This is less, and less, it means that it's on the left, or to the left of 1.52. Okay. Now, let's say I want to find probability that, so this is example number 3. Probability that z is, let's say, larger than, let's say 2.35, for example. Okay, so this is a symbol here. This is larger. Okay, z is larger. So, or in other words, z is more than 2.35. Okay, so this is larger than. Okay, so when z is larger, then the probability corresponds to the area to the right. So this is the area to the right. To the right of, to the right of 2.35. So in other words, you have your graph. This is the graph of your standard normal distribution, right? You have here 2.35. Okay, and you need your z to be larger than 2.35. So if it's larger than, that will be the area to the right. It's larger, so it's more than 2.35. So it's the area to the right of 2.35. Okay. Now the thing is, the table, it doesn't give you the area to the right. It gives you the area to the left. Okay. So this is like a warning. So the table doesn't give the area, so it doesn't give you the area to the right. To the right of z, of your variable, or of your number, to the right of z. Okay, so it gives you the area to the left, right? It gives you the area to the left. Gives you the area to the left. All right. So what do we need? So how do we find? Question now. So how do we compute this thing? How do we find this area to the right? Okay. Well, the answer is the following. So remember what I said, guys, the total area under the graph, it's always one, right? Where is it? You see here. So what I said, the total area under the graph, it's always one, which is 100%. So in other words, you see the region under the graph. So the whole region and the area of the whole region under the graph is one, right? So this blue region here. So the whole region, the area of the whole region under the graph, it's one unit square, or it's 100%. Okay. So to find the area to the right, so what I need to do, I need to subtract, right? I'm going to subtract the area to the left from 1. Okay, so you subtract, because the whole thing is, the whole thing is 100%, right? It's 1. The whole thing is, the whole area is 100%, right? You know the area to the left, and you know the area to the left of 2.35, the yellow region, right? So to get the area to the right, you need to subtract. So we need to subtract the area to the left from 1. From 1, which is 100%. All right. So far, so good, guys. Any question, please? Feel free to interrupt me if you have any question. So yeah, so this is actually equal to 100%, which is the area of the whole region under the graph, minus the area to the left. So the area to the left, that's the probability that z is less, right? That's the area to the left. Z is less than 2.35. So this is the area to the left, because it's less, right? So the area to the left of Z, to the left of 2.35. Okay, you need the area to the right. The table gives you the area to the left. So to find the area to the left, to the right, that would be 100% that the area of the whole region minus the area to the left. All right, so then, so that's 100%, and the area to the left, it's given by the table, right? This is just from the, so this is from the, we can find this area using the table. So from the table, so we're gonna have 100% minus, so 2.35. Any guess, guys? 2.35 will be the area to the left of 2.35. Let me see my table. I'm gonna double check. So it's 0.9906. So this is 0.9906. Okay. So again, I got this number from the table number 3. So yeah, and 100%, of course, it's like 1, right? So minus 0.9906, and 1, you can think of 1 like 1.0000 minus 0.9906. So that's the answer would be 490. Yes, 0 point. Okay, which is in percentage, this is 0.94%. Okay, again, you use 2 digits. You see here 2 digits, and then you put you can place your decimal point after the second digit. So that's 0.94%. Any question, guys? Okay, so we know how to find the area to the left. We know now how to find the area to the right of a number. Now, what about the area between two numbers? This would be my example number 4. Let's say I want to find the probability that my variable z is between, let's say, negative 1.24, for example, and let's say 1.08. Okay, so this probability corresponds to the area of the region. So you have your standard normal distribution right here, and you have your 1 point. This is 1 point, so it's positive 1.08, and then this is negative 1.24. All right. So this probability that your z is between these two numbers is actually between between the negative 1.24 and the 1.08. So we need to find the area of this region, this green region, right between these two numbers. Okay, so this is the area of the green region, right? The region between 1.008 and negative 1.24. And of course, the table in the formula sheet, doesn't give you like the area between the two numbers, right? It gives you the area to the left of one number, right? So so the question, of course, how do we find the area of this region? So how do we? So the formula sheet, the table in the formula sheet doesn't give you the, so we cannot just use, the table number 3. Okay. So we need to find a way to compute this probability, right? And again, the table number 3 gives you the area to the left. So what I'm going to do, I'm going to take the area to the left of 1.08. Okay, so this is, again, here's my 1.08. And so the area to the left of 1.08, it's given by the table. So this area here, it's given by the table. Okay. And then I have my negative 1.24. And the area to the left of negative 1.24, it's also given by the table. Now you can see, guys, the difference between the two areas. I mean, the area to the left of 1.08 and the area to the left of negative 1.24. It's exactly the area of the region needed, right? It's exactly what we need, right? The area of the region between the negative 1.24 and 1.08, right? So the difference between the two areas to the left of 1.08 and negative 1.24, it's exactly the area of the region between these two numbers. So yeah, so what I'm saying is that, so this probability that your z is between negative 1.24 and 1.08, that's actually a probability that your Z is on the left of 1.08. So this is the region on the left of 1.08 minus the region to the left of negative. The region to the left of negative 1.24. Okay. So then the difference between the two regions, that will be the region between, so this is exactly the region between these two numbers. So this is the region, the area of the region between 1.08 and the negative 1.24. All right. Now let's compute this thing. So first we need the area to the left of 1.08. So 1.08, right? This is positive. The nearest tenth would be 1.0, and the nearest hundredth would be 0.08, right? So if you check the table on the second page, of course, this is positive. So it's 1.08. So there'll be 8599. So this is 0.8599 minus, right? And then you have negative 1.24, which is a negative number because of the minus sign, right? You have negative 1.24. So nearest tenth, that'll be negative 1.2. And nearest hundredth, that's the 4. So that's 0.04. Right, so this is negative. So we check the table fee in the first page. So negative 1.2, that would be and 0.04. Where is it? 1.204. So that's point. So this is actually equal to 1.24. That's 0.1075. Right. Again, so these two numbers, they are from the table, number 3. So this is from the table, and this is also from the table. Okay. And yeah, so then the answer would be, so we have 4, 2, and then 5, and then 7 point. Okay, which is if you want to use a percentage, so 2 digits, so that's 75%, 0.24, or 75.24%. All right, guys. So here's an exercise for you. Okay, I'm gonna give you a couple of probabilities. Okay, I think there's one exercise. I didn't have time to go over it last time. So this is, I guess, very similar. This is very similar exercise. So exercise. And this is actually from the textbook. So please try to find using the table, of course. I'm going to use the table number 3. So 1, 2, 3, 4. So first, let's find the probability that Z is, let's see, less or equal to 1.20. Probability that Z is larger than negative 1.20. Probability that Z is between negative 2.18 and negative 0.42. And then last one, probability that z is between, let me see, here's some positive numbers. Yeah, for example, negative 2.20 and 1.40. Let me just make one remark, guys. It doesn't really matter if you have like, just remind you, I mean, this is strictly less, right? This is less or strictly less. This is less or equal, right? Now for the probability, it doesn't matter if it's less or equal, okay? I mean, it's just that you're gonna get the same answer because the probability at one point, at exactly one point, is just 0. So it doesn't change anything if it's less or equal. Same thing for larger. I mean, this is larger or strictly larger, and this is, larger or equal. Okay, but it doesn't really matter if it's larger or equal or larger or equal. It's just the same. It's going to be the same probability, right? So this is again just to remind you. So if you have less or equal, so that's the area to the left. Okay, and if you have like larger or equal, that's the area to the right. Okay. So I'm gonna give you a couple of minutes to think about this exercise. I can probably share the formula sheet in the chat. I think I can share the file. Let me see. Yes, I can. All right, I need to download the formula sheet. Do I have it on my computer? Let me just see 1 second if it's in my computer. Otherwise, I'm gonna just download from the, probably not. Okay, probably not. Okay, so what I'm gonna do, I'm gonna just download from the, okay, it's in the, okay, 23 exam packet. All right, guys, so, okay. Yeah, so the formula sheet it's in the chat, guys. I mean, if you need it, it's in the chat. By the way, guys, please don't forget the homework number 5. It's due well this Thursday. I mean, of course, I know Thursday it's Thanksgiving, but yeah, You know, I just wanted to give you like more time to think about the homework. And again, we do have a class on Wednesday. So, so the next thing I'm gonna do, guys. So this is for the standard. You know, this is for the standard normal distribution where the mean is 0 and the standard deviation is 1, right? And so the next thing we're gonna do, of course, we're gonna try to find the areas or probabilities, you know, for a random variable that follows a normal distribution, which is not necessarily a standard distribution. Okay, so so next section we're gonna try to find, you know, probabilities and areas for random, you know, for random variable for and random normal distribution. It doesn't have to be the normal standard distribution, right? So this is, again, this table gives you the areas for the to the left for the standard normal distribution, which means that your mean it's 0, the average is 0, and the sigma is 1, right? But if you take any like a random normal distribution, right, the mean, it doesn't have, the average doesn't have to be 0, right? So so next we're gonna try to do like a transformation. You know, I'm gonna transform your the random normal distribution to a standard normal distribution. So let me just say, guys, here. So first, this is the number 1. This is the area to the left, right? Because you have less or equal. So this is the area to the left. So this is the area to the left. Here, z is larger or equal, right? So if it's larger or equal, then that will be the area to the right. Now for number 3 and 4, as you can see, your z is between 2 numbers, right? So here it's like z between. So here, so Z is between two numbers. Oh, let me just say one thing, guys. This is an important remark. So before going over the exercise, let me just say, because in the table, the smallest value of Z. So this is a remark, very important remark actually. The smallest value of Z in the table, it's negative 3.49, right? The smallest smallest value of Z in the table is negative 3 point, where is it? Yeah, negative 3.49, right? So you may ask, what do we do for, like, if you have like probability that Z is, let's say, less than negative, I don't know, let's say negative 4.12, for example, right? Negative 4.12, which is, this is, negative 4.12, this is less than, it's less than negative 3.49, right? On your number line, this is like negative 3.49, and then here, this is like, negative 4.12. Okay, and you have your, normal distribution, standard normal distribution, right? You have something like this here. Sorry. All right. Anyway, so if you have a value which is less than negative 3.49, then you can treat this number as just a zero, right? So this probability here is going to be a zero. So you can treat any any area to the left of this negative 3.49 as a zero. Any area to the left of negative 3.49 as just zero. Okay, it's going to be very, very close to 0 actually. So you can just say it's 0. All right. And yeah, this is the smallest number. Now the largest number, it's a positive 3.49, right? In the table, number 3, largest number, it's 3.49. So so if you have a number which is, let's say, larger than 3.49, so the largest value of z in the table, it's positive. So this is here, the smallest one is negative, right? 3.49, and the largest one is in the table, it's actually positive 3.49. So if you have like, you need the probability that z is less than, let's say, positive 4.45, for example, right? So like this is your 3.49 and 4.45, right? It's larger than 3.49. So you know, you have your graph, etc., right? And you need the area to the left of this 4.45, which is not in the table because it's larger than positive 3.49. So you can just treat this area as equal to 1. So this is actually 1. So you can treat any area to the left of any number, you know, larger than 3.49, any number larger than 3.49, 3.49 as 1. So if you have a number which is less than this negative 3.49, so the probability to be that your z is less, or the area of the region to the left, it's 0. If you have a number which is larger than positive 3.49, then the probability that your z is on, you know, on the left of that number, which is larger than 3.49, the probability will be equal to 1. I mean, as you can see in this table number 3, you know, for 3.49, the area is like 9998. So it's almost close to 1, right? So it's very close to 1. Juliana, and the P is 2 or Z? Oh, this number here, that's a Z. This is Z. This is always a Z. This is a variable Z. Okay. Does this answer your question? That's what you mean, right? Okay. All right, guys. So let's so let me go over the exercise. So for number 1, you have z less than 1.20. So for number 1, that's the probability that z is, so this is z less than 1.20. right? So we can just use, so from the table, so the nearest tenth would be, you have your Z. This is positive, of course. So nearest tenth would be 1.2. Okay. And the nearest hundredth would be 0.00. Okay, so then the answer, so from the table, 1.200, that's 8849, right? So this is dot point 0.8849. Okay, so this is 0.8849. So in other words, this is 88.49%. Okay. For number 2, you need your Z to be larger than negative 1.20. So Z is larger than negative 1.20. For number 2, your Z is larger than negative 1.20. As I said, larger or larger or equal doesn't change the probability. All right, so this is larger, right? And if it's larger, then it means that's the area to the right. Okay, this is area to the right. It's not to the left. All right. So as I said, so to find this area to the right, so we need to take the whole area, which is 100%, right? Or 1 minus the area to the left. So minus the probability that Z is less than negative 1.20. All right, this is the area to the left. This one here, this is the area to the left. So the area to the right, it's 1 minus the area to the left, because the whole area is 100%, or 1. So that's 1 minus, then this is, you can get this number, this area from the table. So this is, we can just use the table here. So negative 1.20. So then the answer would be 0.1151. So this is 0.1151. And as I said, 1 is just, I mean, you can use a calculator, of course. But so this is just 1 minus 0.1151. And so the answer would be 9, 4, and then 8, right? And then 8. Okay. Or, so in other words, if you take 2 digits after the decimal point, so that's 88.49%. Right? So far, so good. Right. So number 3. Number 3 is the probability that your Z is between negative 2.18 and negative 0.42. Negative 0.18 and negative 0.42. So number 3, probability that Z is, so again, this is Z. I'm sorry, I'm used to, well, I mean, I can, of course, write Z as like this. Anyway, so Z is between negative, what did I say? Sorry about that. Negative 2.18, negative 0.42, 2.18, 2.18, negative 0.42. So here, this is, so this probability, this is the area between these two numbers. It's between the negative 2.18 and then negative 0.42. All right. So what we do, guys, we take the area to the left. Again, just to remind you the trick here. So here's my negative 0.42, and here's my negative 2.18. So what we do is we take the area to the left of negative 0.42, this one here, and then you remove the area which is to the left of negative 2.18. So you're gonna remove this area, the blue one, to the left of negative 2.18. And that's exactly what we need, right? We need the area between these two numbers, right? So yeah, so this probability here, this would be the probability that your z is on the to the left of negative 0.42 minus the probability that your z is to the left of negative 2.18. So for negative 0.42, the answer, so the nearest tenth, it's a negative 0.4, right? And nearest hundredth, that's a 0.02. So the answer, that's 0.3409. This is negative, minus negative 2.18. Nearest tenth, it's negative 2.1. And nearest hundredth, it's a 0.08. And so the answer is 0.0146, if I'm not mistaken, of course. All right, so then the answer, so we have 3, 6, 2, 3, and point. So then that's 32.63%. All right. Any question, guys? And last one, number 4. So number 4, we need the probability that z is between negative 2.20 and 1.40. So it's the same. The idea is the same, of course, negative 2.20 and 1.40. So this is probability that z is between negative 2.20. Sorry. So z is between negative 2.20 and 1.40. So that's the probability that z is. Yes, any question? Okay, probably not. So z is less than 1.40 minus probability that z is to the left of negative 2.20. Right? So negative less than 1.40. So this is so from the table, this is 0.9192 minus, so negative 2.20. Nearest tenth, it's negative 2.2. Nearest hundredth, it's just 0.00. So the answer is 0.0139, right? And then so that the answer would be 0.3509. So that's 90.53%. All right. Well, I hope it makes sense for you guys. We'll So if you don't have any question, then we can probably move to the next section. So now the goal is, so we know how to find the areas and probabilities, for standard normal distribution when mu is 0 and sigma is 1. So next, the goal would be to find the areas and probabilities for random variable x that follows, some random normal distribution with, the sigma, the mu, the mean and the standard deviation are random. They don't have to be 1 and 0 or 0 and 1, right? So yeah, so that's our next section, 7.3. I guess I can move to the next page here. So section 7.3. So areas under any any normal curve or normal distribution, under any normal distribution. Okay, so as I said, so from section 7.2, so we know how to find areas, or probabilities for standard normal distribution. Using this table number 3. So with the mean is, so the mean and mu is 0 and the standard deviation sigma is 1. All right, using, of course, table number 3. All right. Now, the goal in this section, so the goal today is to find, we want to find areas and probabilities for a random variable x that follows a normal distribution, a random, a normal distribution with mean and sigma, so with random mean, mu, and standard deviation sigma. Okay. So the mean mu and the standard deviation sigma, they don't have to be equal to 0 and 1, like in the normal standard deviation. All right. So so the idea is actually to convert. So we're gonna convert the value of x to the z values. So the idea is to convert. So what we're gonna do, we're gonna convert or transform. We're gonna convert the x values, or the values of x, to the values of z. in the normal distribution. Using, so how do we convert the values of x to the values of z? Well, the z, so we're gonna use a lot this formula. So the z is gonna be equal to the x minus mu. So x minus mu, x minus the mean. So it gives you like the number, the number of standard deviations, between between your so over, of course, here over sigma, the standard deviation. So x minus mu over sigma gives you a number of standard deviations between your x, your variable x, and the mean of your normal distribution. And then, of course, once you convert the values of x to the values of z, then you can use the table, and then use the table. Use the table phi to find the corresponding, areas or probabilities. Okay, so you need to keep in mind this formula, guys. This is a relation between your variable, your random variable x, and the variable z, which is the variable of the standard normal distribution. Of course, so if z is equal to x minus mu over sigma, then x, so this is a remark, you can say that x, in other words, your x is going to be equal to sigma times z plus mu. Right? I mean, these two, these two equations are just the same thing, right? Anyway, so let me give you a couple of examples. So examples. So I can probably use an example from the, from the textbook. So examples. So example number 1. So let's say we have x. So x has a normal distribution. The variable x follows a normal distribution. Okay, it's not the standard normal distribution. It's just some random normal distribution. In other words, the mean, it's not necessarily equal to 0, and the standard deviation is not necessarily equal to 1, right? So this is just a random normal distribution, right? And let's say you want to find probability that x is, let me just erase this thing here. So probability that x is, let's say, larger than, let's say, 90. Okay, and you know that the mean with, that the mean is 100, and sigma is 15. Okay. So as you can see here, the mean, it's 100. It's not equal to 0, and sigma, it's 15. It's not equal to 1, like in a standard normal distribution, right? So what we need to do, guys, we need to convert. So the idea here is to transform or to convert convert x, to z. Sorry, to z. Okay. So what I'm saying is, so this is your probability distribution with x, the variable x. Okay, and here somewhere you have 90, right? And you are looking for, let me do first probability that x is less. Here, I'm gonna do first less, and then we're gonna do, oops. This is, let's say, less first. Okay. So x is less or equal to 90. So that's the area of the region to the left of 90, right? This is 90. So the area of this region, so that's exactly the probability that x is less than 90. Okay. So what we're gonna do, we're gonna convert x to z. So here, I have this is my standard. This is my standard normal distribution, where I can use, the table number 3 to find the areas and probabilities. So here's my standard normal distribution. I know that, the mean is supposed to be 0, and sigma is 1. You know that sigma is 1, right? So yeah, so the idea is to convert this 90, x here is 90, right? So I'm gonna convert 90 to z. So the relation again between, z is, we said z is equal to x minus mu over sigma, right? X minus mu over sigma. So what's x? So in this problem here, we need, so x to the left of 90, right? So we need to convert this 90 to the variable z. So x is 90. So this is 90 minus mu, right? So what's the mu in this problem? We said mu is, it's 100. So it's minus 100 over sigma. So what's sigma in this problem? Well, it's 15, right? So it's over 15. Okay, so then z, the variable of the standard normal distribution, is going to be equal to, so the 90 corresponds to, so 90 minus 100 over 15. So 90 minus 100, that's negative 10 over 15, right? So that's negative, negative 2/3, which is equal to, of course, 0.6. Let's say, so this is 0. Negative. Sorry. So this is negative 0.6. Let's say 6.6 or 6.7 if you want to round this. So it's let's say negative 0.67. Okay. Yeah. So now, so that's so what we are saying here, guys, is that, so this you see this 90. So this 90 corresponds to, in the normal standard distribution, corresponds to negative 0.67. Okay, or in other words, so this probability that x is less than 90, this is the same as the probability that z is less than this negative 0.67. Okay. And now I can use, I can use my my table. So here I can use my table number 3, right? Because now my variable, it's the variable z. That's the variable of the normal, of the standard normal distribution, right? So yeah, so then that will be equal to, so let me just check my table. So this is equal to, in the table, so negative 0.667. So the nearest 10th, that's negative 0.6. And nearest 10th, it's 0.07. So the answer is 0.2514, right? In other words, this is 25.14%. Okay, so again, here in this probability, your x, your variable x, has a normal distribution. It's not the standard normal distribution, right? So we cannot use the table. The table, it's for a standard normal distribution where the mean is 0 and the standard deviation is 1. So here, and for this variable x, so for this variable x, the mean, it's actually 100, and the standard deviation is actually 15. So what we do, as you can see, I converted my 90, my x equal to 90, right, in this normal distribution, to my variable z in the standard normal distribution. So when you convert, the formula that you need to use is this one here, right here. X minus mu over sigma. It gives you the number of the standard deviations from the mean in the standard normal distribution. So yeah, so your x, you want to convert this 90, right? So x is 90 minus 100. It's given in the problem. You know that, as you can see, you know that the mean is 100 over the standard deviation, right? That, which is 15, right? So that's negative 0.67. So my z is, negative 0.67, and then I can use, my table, to find the corresponding area or probability. Any question, guys? All right, so that's for, so this is first example. Let's do more examples. So this is for x less than 90. Now, if you wanna x larger. So example number 2. Let me just take another example. I can take another example from the, from the textbook. Let's take x, probability that x is larger or equal to 30, with mean mu is 20, and the standard deviation sigma is 3.4. Okay. So x is larger than 30. This is the area to the right. Right. This is the area to the right of 30. To the right, because it's larger, right? This is larger or equal. So it's to the right of 30. Okay. So So in your normal distribution, let's say this is the graph of your normal distribution. Here is 30, right? And you need the area to the right of 30. Okay. So what am I gonna do? As I said, we're gonna convert, or we're gonna transform your variable x to the variable Juliana, you're saying you didn't finish last week exercise? Well, actually, I did the similar exercise. You know, in the previous section, I did a very similar problem. I mean, it's just the same. The idea is the same. Because I don't have the. I mean, I don't have really the exercise in front of me, but I mean, I did a very similar problem in the previous section. But I mean, I can do it next time. Okay, just you can just remind me what was the exercise, and then I can go over it. Okay. Yeah, and so we need to transform or to convert this 30 to the variable z. So here we have z, the variable of the standard normal distribution. Again, here's your graph. You're supposed to have like the mean here, mu is 0, right? This is the standard. This is the standard normal distribution. Okay. So what we do is we need to convert this 30. See this 30 to the variable z. So then we can use the table, our table in the formula sheet. So so to convert 30, we need to use, as I said, so z is x minus mu over sigma. So in our problem here, x is 30 minus mu. Mu is, so in this example, mu is 20. So you see, guys, I mean, the mu, the mean, it depends on the problem. It's not always the same, right? I mean, in the previous example, example number 1, mu was like, you know, was like 100, right? So as you can see in the previous example, the mean was 100. Here in this example, the mean is 20, right? So the mean depends on the problem. And in the standard normal distribution, the mean, the average is it's actually 0. Yeah. So anyway, so it's x minus mu. Mu is the 20. So 30 minus 20 over the sigma. Sigma is the 3.4. All right, that's 30 minus 20, that's 10 over 3.4. So then that will be equal to, let me see my notes. That's equal to, let me just see my notes. Where's the answer? So yeah, so it's a 10 over 3.4. So that's equal to 2. So this is 2.94. Okay. So what I am saying is that if you convert your 30 to the z, then 30 becomes 2.94. Okay. And of course, you need, again, the region to the right of 2.94. Okay. So in other words, so this probability that x is larger than 30, this is the probability that z is larger equal to 2.94. So this is equal to, so this is to the right, right? Z is larger than 2.94. to the right. So it's not to the left. So you cannot just use the table, right? So that's actually 1 or 100% minus the probability that z is less than 2.94, or the area to the left, right? One minus the area to the left. Now the area to the left, you can use the table. So here you can use the table. So this is 1 minus, so probability that z is less than 2.94. So let me see. So from the table, 2.94, the nearest 10th is 2.9, nearest 100th, it's 0.04. So then the answer is, this is 1 minus 0.9984. Right, so that's 0.0016, right? Or in other words, this is 0.16%. Okay. So one more example before the exercise, guys. Just see here. All right, one more example. So example number 2, example number 3. So again, I'm gonna just take an example from the textbook. So let's say probability that x is between 8 and 12. And mu, the mean is, you know that the mean is 15, and sigma is 3.2. Okay, so this is equal to probability that, and then as I said, so we're gonna convert. So you just convert your variable x to the variable z. So here you're gonna have, so here's z between, so the 8, so we're gonna convert 8, so that's 8 minus, 8 minus the mean, the 15, over the sigma, the standard deviation, so 3.2. And here it's the same thing, so it's 12 minus 15 over the 3.2. All right, so again, the formula I'm using here is, I'm using the fact that z is x minus mu over sigma, right? This is like my x minus mu over sigma, x minus mu over sigma. Okay, so that will be equal to, so this is a probability that x is, or z, sorry. So here it's 8 minus 15, that's -7 over 3.2, less or equal to z, less or equal to 12 minus 15, that's -3 over 3.2. So this is a probability that, so 7, so 7 over, let me check my notes. So 7 over 3.2, that's negative, don't forget there's a negative here. So it's negative 2.187, I think. And this is z, negative, so 3 over 3.2. So that'll be equal to 0.93. So now I can use the table. So my z is between these two numbers. And remember, guys, this is just, the probability that z is between these two numbers, that will be the probability that z is, first less than, to the left of negative 0.93, minus the probability that z is to the left of negative 2.18. Okay, so then here I can use my table number 3. So probability that z is less than negative 0.90, I can use the table. Nearest tenth is negative 0.9. Nearest hundredth is 0.3. So that's 0.1762 minus 2.18. So that's 0.0146. Okay, from the table. So then the answer it's point. So it's 6, 1, and then 4, 0. Sorry, that's not 4. So it's a 7 minus 1. This is a 6, of course. Oops. It's a 6 and then 1. Okay, so that's equal to, in other words, this is a 16.16%. Okay. So yeah, so the idea, guys, is if you have a random normal distribution with a random arbitrary, mean and standard deviation. So the idea is to convert your variable x to the variable z and then use the table, right? So here's an exercise for you. So exercise. I'm gonna give you a couple of minutes to think about this. So I'm gonna just take an exercise from the textbook. So let's say you wanna find probability that x is between 10 and 26. Okay, if you know that the mean, the average is 15 and the standard deviation is 4. Next, probability that x is, let's say, larger than 2. If you're, no, not this. I don't like this example. So let's see another one. Yeah, let's take this x larger than 120. And you know that mean is 100 and the standard deviation is 15. All right, and the last one, probability that x is between 7 and 9 with mean equal to 5 and standard deviation equal to 1.2. So again, the idea, guys, is first step, step 1, you need to convert step 1. So you need to convert x to z using, the formula that, so z would be like x minus mu over sigma, right? So for example, in the first, you have like 10 and 26. So we need to convert 10 to z in the standard normal distribution, and the same for 26. You need to convert your 26 to some value of z using this formula here, right? And then in the step number 2, you need to use the table. Step 2, use your table. And then after that, guys, I think we can have some, real life problems. And we'll see how to use this formula, how to convert this x to z. And next, you'll see sometimes you need to actually to convert z to x. You need to go from z to x, and it depends, of course, it depends on the problem. I guess we're gonna have time to solve this problem, solve this exercise, and then yeah, we're gonna have more different kind of problems. As I said, like more real life problems, and then we see some problems where you have to convert z to x. So here we are converting x to z, right? But sometimes, as I said, sometimes you have to convert the z to x. Am I recording? Yes, I'm recording. Okay, perfect. Um, Yeah, I'm gonna probably have enough time to solve this exercise, but I don't know if we're gonna have time to move to the next. We'll see. Well, yeah. So I'm gonna give you a couple of, let's say 2 more minutes, guys. Of course, if you need more time, just let me know. Oh, Candy, by the way, I mean, if you need the notes of the last Wednesday, let me know. I mean, I can always send you the notes.
Yes, Professor.
Okay. Let me check if I have your email. I think I have your email. Candy. Yeah, the BCC email. Yes. Okay. All right. All right, guys. I don't. Does anyone need more time to think about this exercise? Okay, no one. Okay, perfect. All right, so let me go over this. So for number 1, so as I said, first step, you convert your x to z. So number 1, so we have this probability that x is between. So x is between 10 and 26, right? So this is equal. Now I'm gonna convert this to z. And the way to do it is, as I said, we need to use this formula right here, okay? And as you can see, the first problem, the mean, the mu is 15. So this number here, this is 15. And the sigma, the standard deviation, is 4. So this number here, it's 4, right? So if you have 10, so then you have like 10 minus, you have 10 minus 15 over 4. And then here it's a 26, so it's 26 minus 15, the mu, the mean, over the sigma, the standard deviation, which is, again, it's 4. Okay. So again, it's x minus, it's x minus mu, which is 15, over sigma, which is 4. So if you have 10, that's 10 minus 15 over 4. If you have 26, that's 26 minus 15 over 4. All right. So then this is just 10 minus 15, it's negative 5 over 4, your z, and then it's 26 minus 15, that's 11 over 4. Now, if you divide negative 5 over 4, that's negative 1.25, less or equal to z, less or equal to 11 over 11 over 4, which is 2 point, so this is 2.75. All right, this is like the first step. we are done with the first step. We converted your x, the x to the z. All right, now next step, step number 2. So this is, let me just write down here. This is like step 1. So like step 1, right? Now, step number 2. And the step number 2, I can use my table, right? Because this is in terms of this probability. It's in the terms of the z, the variable of the standard normal distribution. So now I can use my table first. So this is a probability that z is between these two numbers, right? The negative 1.25 and 2.75. So it means that this is actually a probability. This is the area to the left of 2.75. That's like the largest number here. So z is less than 2.75. The area to the left of 2.75 minus the area to the left of negative 1.25. Okay, so whenever you have like your z between two numbers, so then that's a probability of the z less than the first number, I mean the largest number, which is 2.75 in this case, then minus probability that z is less than the other number. Now I can use my table. So here I can use my table number 3. So z less than 2.75. So nearest it's positive, of course. So nearest hundredth, nearest tenth, it's 2.7, and nearest tenth, it's 0.05. So this is 0.9970. This is again from the table. Minus, now this is negative, right? It's negative 1.25. So nearest tenth, it's negative 1.2. And nearest hundredth, it's 0.05, which is, so this is 0.1056. All right, so then the answer, so it's going to be this is 4.19, and then 8, which is 89.14%. Okay. Any question, guys? How I got this 89.14%? Let me see the chat. No. Okay. All right. So yeah. So this is number 1. For number 2. So we have, let's see, number 2, it's x larger than 120. So it's probability that x, it's larger than 120. The mean in this problem, it's 100, and standard deviation is 15. So this is 100, standard deviation is 15. Right, so in the first step, we need to convert this to the variable z. Right, so this is equal to the probability that z, and then you have 120. So again, z is x minus mu over sigma. So we have 120. So that's 120 minus mu, which is 100, over the 15. That's your standard deviation, so over 15. So this is a probability that z is, so 120 minus 100, that's 20 over 15. So this is probability that z is larger than, so 20 over 15. Let me just check my notes. It's 1.33. All right. So that's the first step. Now, second step, I can use my table, but first, let me just say, so this is, as you can see, this is a z larger than. Larger than means it's the area to the right. And to find the area to the right, you need to subtract the area to the left from 1, right? So this is 1 minus the area to the left. So that's like z less than 1.33. So so from the table, because the table gives you the area to the left. So this is 1 minus, so 1.33, let's see. So nearest tenth, it's 1.3. Nearest hundredth, it's 0.03. So the answer is actually, this is 0.9082. So this is 0.8 1, right? 9 0, which is 9 after 2 digits. So that's 9.18%. 9.18%. Okay. So that's for x larger than 120. Last one, guys. So number 3, it's x between 7 and 9, right? Mean it's 5, sigma is 1.2. So 7 and 9. Let me see if there's any question in the chat. We never know. Okay. All right, no questions. Okay, perfect. All right, so this is number 3. So probability that x is between 7 and 9, we said. And we said the mean is, where is it? Mean is 5 and standard deviation is 1.2. So mean is, mu is 5 and standard deviation is 1.2. All right, so as a first step, we convert this to the variable z. So step 1, we're going to convert this to the variable z. So here's now my variable z. Now this is 7 minus, so it's x minus mu over sigma. Z is x minus mu over sigma. So it's minus 5 over 1.2. And here it's 9 minus 5 over 1.2. So this is 7 minus 5, it's 2 over 1.2, less than z, less than 4 over 1.2. Now, 2 over 1.2, that's a probability that 2 over 1.2, it's 1.67. This is z. And let me check my notes. So 4 over 1.2 is, yeah, it's 3.33. Okay. Now, next step. So we're going to try to use the table. Step 2, use the table number 3. So, well, first, so we need to understand that this is the probability that z is between 2 numbers. So if your z is between 2 numbers, then that will be the probability that z is less than the largest number, which is 3.33. So that's the area to the left of 3.33 minus the area to the left of 1.67. So now I can use my table. So z is less than 3.33, that's positive. So the nearest tenth is 3.3, and the nearest hundredth, it's 0.03, which is, so then the answer from the table would be 0.9995 minus, now this is of course z, right? The variable is z. 1.67. 1.67 nearest tenth, it's 1.6. Nearest hundredth, it's 0.07. So the answer, is 0.9525. So then, so the answer would be 7, 4, and then 0. So that's equal to, so 2 digits. So that's 4 point, sorry, did I do my mistake here? No, it's okay. 7, this is a 0, right? Here's, we have like 0, but it doesn't matter. 9, 9, 12, and yeah. So it's, so it's 4.7%. Okay. Is there any question, guys? All right. So then, well, how much time is left? Okay, it's like 7 minutes. I don't know if we can do, well, let me just write down like, so next. So let's do some real life problems, okay? So I'm gonna give you just one example, and probably, I mean, I won't have time to solve the problem today. So I will just solve the problem on Wednesday, and then I will try to give you, of course, more problems on Wednesday. So yeah, so exercise. Well, we have the Blu-ray players. They have a normally distributed functional life. Okay, so again, what we are saying here is that the functional life of the Blu-ray players, it follows a normal distribution, right? So the variable X here, that's the functional life of your of the Blu-ray player, right? So and we know that the mean, with the mean mu, it's, let's say, the average of the functional life of the Blu-ray players is 2.3 years. Okay. And standard deviation, sigma. Sigma is 0.4 years. Okay. So the question is, so what's the probability that the Blu-ray player will break down during the guarantee period. So the guarantee period is 2 years. The guarantee period of 2 years. Okay, so let's first, how much time left? 5 minutes. All right. Well, I don't know if I'm going to solve completely this problem exercise today, but let's try to understand this the exercise first. So what we are saying here is first the functional life of the Blu-ray players actually follows a normal distribution, right? So like if the variable x is the functional life, the variable x, that's a functional life of the Blu-ray player. Okay, that's a variable x, and it follows. So this variable x follows a normal distribution. Okay, some normal distribution. But we know that the normal distribution of this the functional life of a Blu-ray player is actually the mean. So with, as you can see, the mean is 2.3 years. So so the mean is 2.3 years. Okay, and standard deviation sigma, it's 0.4 years, of course. So we are looking for the probability that that the Blu-ray player will break down during the guarantee period of 2 years. Okay, so we want the probability that the functional life of the Blu-ray player is less than 2 years, right? That's the guarantee period, right? The guarantee period is 2 years, and you need the probability that the Blu-ray player will break down during the guarantee period, right? So we need the probability that your functional life, the functional life of your Blu-ray player is less than 2 years, which is the guarantee period, right? So the question here is what's the probability that x is less than 2, right? Again, x, that's the functional life of your Blu-ray player, and you want to know when the probability that your Blu-ray player will break down during the 2 years. So before 2 years, right? So we want to find the probability that x is less than 2. The functional life of the Blu-ray player is less than 2 years. Okay, so that's what we need to compute, that the x, the functional life of the Blu-ray player is less than the guarantee period, which is 2 years. Okay, so anyway, so whenever you have similar problems, guys, you need to, of course, you need to understand, you need to read carefully the problem. You need to know exactly what's your x, what's the variable x, what's the mean, and what's the standard deviation, right? I mean, again, the mean and the standard deviation are given in the problem. And but then, of course, you need to understand what you have, what's the goal of the exercise. So what do you need to compute exactly, right? So like here, we need the probability that the Blu-ray player will break down during the guarantee period of 2 years. So you need that the functional life of your Blu-ray player less or equal to 2. So it's going to break down in 2 years or less. Okay. So this is a probability that x is less or equal to 2, or strictly less than 2. That doesn't change anything. And then, of course, so then next step, how much time? Oh, okay. So then, yeah, so next step, of course, step 1, you need to convert, x to z. And then step 2, you need to, use the table number 3. Okay. Anyway, guys, I'm gonna stop here. So I promise, Juliana, I will solve this on Wednesday. Okay, I promise I will solve this on Wednesday, and we'll do more exercises. Okay. Thank you for listening, guys. Thank you, Juliana, Candy, and Aideen. And yeah, Hope I'm going to see you on Wednesday. Right. Good night, everyone, and thank you for listening. Good night, Aileen. Thanks.
Good night, Professor. Good night, everyone.
Good night, Candy. Thank you.